So for each of these graphs, we're going to decide whether velocity and acceleration would be positive, negative, or zero, and that's going to help us indicate whether an object is slowing down or speeding up. So pretty much if the acceleration and velocity have the same sign at a particular time, then the object is being pushed in the direction of the motion and the object is speeding up. So if I have my velocity and my acceleration both with the same sign, they're both positive, or in fact both negative, then that means that we are speeding up. If my acceleration and velocity have opposite signs at a particular time, then the object is being pushed in the opposite direction to its motion, and it's actually slowing down. So we'll go through that again in a little bit, or as we move along. So let's take a look at this first graph. We can see that the slope of the tangent here along this curve is always going to be positive, so my velocity is positive, and then that slope is going to change and actually decrease, so my acceleration is negative. So what that means is that here we have opposite signs, so that means that we're slowing down. So we've recognized that one is slowing down. Let's take a look at the next one. Again, with this one here, our velocity is positive, but when we take a look at our acceleration, we are actually increasing, okay? So our acceleration here is positive as well. So this means that we're speeding up. For our third graph, we have our velocity as being positive too, so think about the slope of the tangent at any point. So our velocity is positive for this one, and when we look at our acceleration and the change in velocity, we can see that it doesn't change, right? It maintains the same slope all the way along. So that means that it's equal to 0. So for this one, we have a constant speed. Our last one here, we have our velocity is being negative, so think of the slope of the tangent line. Our acceleration for this one again is also 0, so we are also maintaining a constant speed for this one as well. When I take a look at the next graph here, I have a negative slope, so my velocity here is actually negative. When I think about my acceleration, I have, sorry I'm a little bit off today, but I'm getting more negative, okay? So as my t increases, I'm actually getting more negative, so my acceleration here is negative. And so because they're both the same sign, we actually have the object speeding up. Our next one, again, has our v at t as negative, but our acceleration is actually going from negative to 0, right? So our acceleration is actually positive here, so that's our change. And so because they are opposite, we are slowing down. Our last two, we actually have changes going on. We can take a look at the change in concavity in both of these and recognize that we have our velocity and our acceleration changing actually in two pieces. So we can split this into two parts. So we'll say part 1 and part 2, and we can refer back to our other graphs to take a look at what's happening, whether we're speeding up and slowing down based on our velocity and acceleration in these two pieces. So for part 1, we have a velocity that is positive, so our v at t is positive, and our acceleration is actually negative. And so in this case, we are slowing down. When we take a look at part 2 for this one, we can see that our velocity is positive and our acceleration is also positive, and so therefore we're speeding up. So in that graph, we go from a place where we're slowing down to a place where we are speeding up. For the last graph, I want you to pause the video and split it into two pieces and try and think about what your velocity and acceleration is doing in both of those pieces, and then determine whether it's speeding up or slowing down. So pause the video, and then I'm going to let you know if you're right or wrong, so then you can keep playing and I'll have the answer up for you. So for part one, we have velocity that's negative, acceleration that's positive, so we're slowing down. They have opposite signs. And for part two, our velocity and our acceleration are both negative, so that means because they both have the same sign that they are speeding up. So we're going to take a look at an example where we have a race car that is modeled by our function s at t, where t is in seconds, s is in meters, so that's our displacement. We want to know, the first question is, after how many seconds does the race car stop? So really what we're looking for is the time when the velocity is equal to 0. So we want to go ahead and solve for when our velocity is 0 and solve for time. So first I need to find out what our model for velocity is, and we know that that's just the derivative of s at t. So when I take the derivative, I get negative 3 over 5 t squared plus 12t. And then I'm going to set it equal to 0. And then I'm going to go ahead and solve. So I'm going to factor this. I'm going to factor out negative 3 over 5t, which leaves me with t minus 20 over here. So I have two values for t that make this true. I have t is equal to 0, so when time is 0, and when time is 20 seconds. So obviously the car was stopped when t was 0, so our conclusion here is that the car stops at 20 seconds. Our next question that we're going to ask is, at what time does the race car brake? So pretty much, when do we start slowing down? So our velocity is still positive, we're still moving, but when is our acceleration equal to 0? So, and that will be when we first hit the brakes. So we're looking for when a at t is equal to 0. So first off, we need to find our equation for a at t, which is the derivative of v at t, which gives us negative 6 over 5. There's a negative out front there, t plus 12. And then we're going to set that equal to 0. So 0 equals negative 6 over 5t plus 12. And we just can rearrange this and solve. So I'm going to have negative 12 and then divided by negative 6 over 5, which just means multiply by negative 5 over 6, and that's going to go ahead and equal to t, and then t would equal to 10. So therefore, the car begins to brake at 10 seconds. So the car begins to brake at 10 seconds. So now we're going to take a look at whether or not the vehicle is slowing down or speeding up at 6 seconds and 15 seconds. So again, we're going to compare the velocity and acceleration at these two times. So let's first start with at 6 seconds. So when t is equal to 6, we're going to start by taking a look at our velocity at 6 seconds by plugging it into our equation. So we have negative 3 over 5 times 6 squared plus 12 times 6. And that gives me 252 over 5, which equals 50.4 meters per second. And so my velocity here we can recognize as being positive. My acceleration at 6 seconds is equal to 4.8 meters per second squared. So all I did was plug in 6 into our acceleration function. And because this is positive, our velocity is positive, and our acceleration is positive, that means that at 6 seconds we're actually speeding up. So go ahead and take a minute to fill in your conclusion. And now we're going to take a look at 15 seconds. So when t is equal to 15. So I'm going to plug in 15 into my equation for velocity. So I get negative 3 over 5 times 15 squared plus 12 times 15. And then when I expand, simplify, multiply, I get 45 meters per second. Again, we have positive velocity. And when I find my acceleration at 15, I have it equal to negative 6. And this is meters per second squared. And this is a negative value. So because they are opposite signs, we know here that we're slowing down. Therefore, at 15 seconds, the vehicle is slowing down. Lastly, we're going to take a look at sketching the graph of our velocity and acceleration for these two particular distance graphs. So let's take a look at our first one, which we can recognize as a cubic function. And this cubic function we can see has places where our slope of our tangent is 0. It's not quite on the line, but you get the idea. And we can also analyze our slope at other places on the graph. Here are areas where our slope is negative over here. Here's a positive slope here, and here's negative slope here. So again, this graph up here is our S at t. And so when we start taking a look at its velocity, we know that the velocity is 0 when the slope of our S at t is 0. The slope of the tangent is 0 up there. So these are the two places that where my velocity, my v at t, are equal to 0. So in between those two zeros, we know that we have this positive slope, so our velocity is actually positive, which means our y values for velocity are positive. And on either side of those zeros, we know our velocity is negative, so our y values for velocity are negative. So this is our sketch of our velocity function. And we can see here that this is a quadratic, which should make sense to us since we started with a cubic and our velocity is the derivative of that cubic function. So now we're going to take a look at our acceleration function. So down here, when taking a look at our velocity function, actually let me bring it down a little bit more, we are going to start like we did before by taking a look where that slope of the tangent is 0, and that's where we know our acceleration is equal to 0. So here would be the 0 for my acceleration, and then we can see at our velocity function here that we have a positive acceleration on this side and a negative acceleration on this side. So that would mean when I'm drawing my function that I have positive y values on this side of my 0, and then I have negative y values on that side of my 0. And that line is supposed to actually connect into a straight line, but you'll be using a ruler. And this is my acceleration function. We can see that if we start with our quadratic function for velocity, then our acceleration is going to be a linear function. So now I'm going to have you try one of these on your own. So you're going to start with this quartic function at the top. I want you to go ahead and use this as your S at t. And then you're going to graph your velocity, and then at the bottom you're going to graph your acceleration function. So you're going to start again by finding the zeros of your velocity and then placing those on your velocity graph, and then looking where your values are going to be positive and negative for velocity, and then continue on and do the same thing with acceleration. And that's where we're going to end tonight, and then we're going to take up your graphs at the start of class tomorrow.